All right, so we are going to do a recap. Sorry, I'm just trying to adjust the
of BCR 2.3. So this is ionic bonds. The objective says explain how the bonds are formed, which we'll talk about within our examples, and then also write formulas of compounds if given two atoms, which again we're going to do in our examples, and then write the name if given the formula, or write the formula if given the name. And there's a bunch of practices on this on Schoology, but for these kind, I'm just going to just give two examples of those. So let's first take a look at an example. So we have sulfur and potassium. Sorry about that. Sulfur and potassium, if we remember back to ionic, ionics form between cations and anions. So our cation is potassium and sulfur is our anion. And when we're talking about ionic, your cation always comes first and your anion always comes second. So that will matter when we're talking about and we're actually trying to name these things. So the first thing that I want to do is I want to show you the two different models. Okay, so the first one we'll do is the Lewis dot model. So potassium, if I was on my periodic table, is K and it has one valence electron. Okay, sulfur is in group 16 and it has 6 valence electrons. Okay, so what our whole point of this is ionics, the cation wants to give all of its electrons to the anion, and if it gives all of these electrons away, it is empty, but technically it's full because the previous shell is full and then this one is full. So we want to make sure that we have full shells for both of them. Again, we're giving them away, but the previous shell is full. So if I do that, potassium can give sulfur one of its electrons. So it's going to do that, and I'm going to cross that out, and I'm going to put that down here. Okay, so now potassium is empty, however, sulfur is not full. So what we can do is we can add another potassium, and if I do that, I then have an extra electron that I can give there, and now I have this. So in order to make potassium and sulfur, in order to combine them together, I need 2 potassiums to fill out 1 sulfur. So my formula here is K2S. Okay, and we'll see the same exact thing on my next one. All right, so the next thing, this is the Lewis dot, the ionic charge model. If I go back to potassium and I know it has 1 valence electron, it's going to have a +1 charge. Okay, and if I go back to sulfur, sulfur has 6 valence electrons, so it's going to have a -2 charge. When we're talking about ionics, yes, we're giving and taking electrons, but when we do that, we have opposite charges. That's what makes these things stick together. These are like magnets, and they only will be complete if you have the same amount of positives as you do negatives. Sorry, that's a really bad 2. So right now, I have +1 over here and -2 over here. I cannot change these two. However, what I can do is I can add another potassium. So this one then give me +2 and -2, and if those cancel out, I'm then left with K2S. So now I have both of these in 2 different ways. I've shown that both, when I have Ks, I can have 2 Ks combined with 1 S. The name for this is potassium sulfide, okay? So again, when we're talking about ionic, you never have prefixes. You always have just the metal or the cation and then the anion ending in "ide." So potassium sulfide. So make sure formula and name, your metal or your cation always comes first, okay? So that's a pretty basic example. Let's go to a harder one now. So the more challenging one would be magnesium and nitrogen. So again, let's start with a Lewis dot. So let's do magnesium first. Magnesium has 2 valence electrons, and nitrogen has 5. Okay, so if that's the case, again, I want all of this to be empty and all of these to be full. All of these electrons are being taken away from the metal and giving it to the non-metal. Okay, so if we look now, magnesium has 2 to give. Well, nitrogen actually has 3 spots. So what we're going to do is we're going to take away those 2 electrons and we're going to put them here. Well, that's good. That's empty. However, this isn't full. So what we're going to need to do is we're going to need to add another magnesium because we haven't met that goal over here. So if I add another magnesium I then can take one of those electrons, this one, and I'm going to give it over here to that. So now this one's full, okay? But if you see now, I have not given rid of all of my electrons here. So I'm going to actually have to add another nitrogen. Oops, I did that wrong. Okay, so when I add another nitrogen, I can put that electron that was over here, here. But now I need 2 more electrons. Well, the next thing that I would do is just add 1 more magnesium, which has 2 more electrons. I then can get rid of those 2 and bring them over here. So now I have 3 magnesiums to fill out 2 nitrogens. So my formula becomes Mg3N2 because I had 3 magnesiums and I had to give all of those electrons to the 2 nitrogens to make that a complete shell for both of those. Okay, so if we're going to show the ionic charge model for this, Mg has a positive 2 charge, nitrogen has a negative 3 charge. What we can look at is the lowest common multiple between 2 and 3. Well, 2 and 3 both can go into 6. So if I want to get to 6, I need 3 magnesiums. So I'm going to write out magnesium 2 more times. And I'm going to write out nitrogen
Attention, please.
1 more time.
Jonathan
Sorry, there's a lot of interruptions today. So we have 3 magnesiums to get positive 6, 2 magnesiums to get to negative 6. So again, these are going to stick together because they have opposite charges, and they got opposite charges when they lost or gained their electrons. So the formula, again, that we can get is Mg3N2. And if we are naming this, since it's ionic, it never has prefixes. It is magnesium nitride. Your cation, your metal, always comes first. Your anion always comes second, and it ends with "ide." Okay? So big thing here, ionics, if you were ever given the name, you have to do your work to figure it out. Okay, so you'll see that a lot in the mixed practice when you do 2.2, 2.3, when you're getting ready for that combined assessment. So just be careful. When you see this, you have to first determine if it's ionic, and if it's ionic, then you have to do some work of some kind in order to determine what your chemical formula is. All right, if you have questions, please let me know. There is a ton of extra practice on Schoology. Big thing is, when you're doing this, you need to know the role of the electrons is the cation is giving it to the anion, and because you have opposite charges, you guys are going to stick together, okay? And then also being able to do all of this, being able to create them, being able to give the name if you're given the formula, or give the formula if given the name, okay? So let me know if you have any questions.